A derivative is looking at the rate of change of a function. We know what our average rate of change is. It's given by our change of our function over our change in our input. But how can we apply this to a function? Well, you may remember looking at this one, but we're going to look at it again, looking at a point here and seeing how the rate of change can be affected. So we now have a point on our graph, which has an input at x, and this point here has an input value of x and has an output value of f of x. And we're looking at very small changes in our function to give us our derivative. From our previous video, we saw that the derivative was looking at that small change, so x plus h, minus our original part of our function, f of x, over our change in our function, which was the x plus h minus x, where those two cancelled, those two x's here and here cancelled, and what we ended up being left with is just an h on the bottom. But this still gives us two distinct points. So we needed to take the limit as h tended towards 0. But what does this really mean? Well, let's look at our function. And if this is our change here, this is our change of x plus h, and this is our tiny point up the top here. But that still gives us two distinct points, and it's not going to give us a perfect shape of the curve. So what we need to do is change it so it becomes smaller and smaller and smaller until the h is exactly on it. So to find our derivative, we first need to simplify this area and then take it to when h is equal to 0. And the way we write this is our derivative, which is symbolized here by this prime, and we take our derivative of x is equal to the limit as h tends towards 0 of our function with a small change minus the point that we're actually interested in divided by our small change. This will give us the derivative of any function, and what we can use that is to find the instantaneous rate of change at any individual point along our function.